principles and traditional methods of food protection and preservation, which includes physical methods, chemical methods, biological methods. In this chapter, we deal with the following aspects: preservation of contamination, general principles for preventing food contaminations, food preservation methods, removal / restriction of microbes, methods to control microorganisms in food processing. Introduction. Nature provides protective covering around the food. It may be in the form of shell of nuts, dry skins of cereals, or thick skins of fruits and vegetables. In animal based foods, the shell of eggs, the rubbery skin or fat layer on meat or fish provides the protection. These protective covering can also prevent or delay microbial colonization and further decomposition. The aim of food protection and food preservation is to prevent contamination and spoilage of food. A number of food preservation methods are used today and their origin dating back to ancient time. Physical methods of food preservation includes methods like dehydration, freezing, cold storage and heat treatment. The standards for the number of microbes permitted in various foods are specified in our country by Food Safety and Standard Authorities of India or FSSAI. Every company or person dealing with food commercially needs to take approval from FSSAI and adhere to the conditions laid by them. This is mainly to prevent the spoilage of food and further to take care of the consumer's health. This also lays down the standards for containers, preservatives, nutritional condition, contaminants and storage. The details of FSSAI law will be dealt in another chapter. Prevention of contamination. The food should be clean and neat with minimum contamination from the field. Food can be damaged either by insects, animals or by mishandling. The damaged portions are then exposed for microbial attack. Therefore, care should be taken to minimize any damage to the foods. This can be achieved by cleaning the food in the place where it is grown or reared. The food material should be washed and dried before it is packed in appropriate containers. One of the important places for the spread of contamination is the packaging material and market floor. Hence, it is advised to wash, clean and separate the good material from the spoilt ones before it is taken inside our house or the processing units. Food handlers hygiene. One of the most important ways of preventing contamination is by adopting a good food handlers hygiene. This includes a set of practice that should be followed by all the persons involved in handling food at every stage of the food supply process. Food handlers hygiene in both retail and commercial premises where the food and drink is sold to customers is of critical importance. The same principle should also be practiced at domestic premises. The importance of good food handlers hygiene is to prevent the food contamination and spread of disease, to ensure the good health of people eating the food, to protect the health of the food handlers. All the food handlers should avoid bad habits such as scratching, touching the hair, nose or mouth, having unclean hair, unclean and long fingernails. Food handlers should refrain from smoking, coughing or sneezing in food handling and preparation areas. They should be healthy and should not be carrying any contagious disease like skin infection, diarrhea or sore throats. They should always wash their hands before they enter the premises where food is prepared or handled and after using the toilets. General principles for preventing food contamination. Some of the general principles for preventing food contaminations are: water used in food preparation should be of a good quality and adhere to the standards specified by FSSAI. All the utensils must be kept clean and covered. All surfaces that come in contact with food should be well cleaned. The area used for storage, preparation and serving of food should be free of pests, rats and insects. All types of prepared food should be clearly labeled and covered. Food and the utensils should be kept separate from chemicals and poisons. Cloth and handling aid that come in contact with dishes and utensils that are not used to cover the food need to be changed daily and washed in hot water before use. During storage or preservation of food, the conditions which are congenial for the spoilage system has to be restricted. Like we humans, microorganisms also need food and water. Further, they also need a suitable pH and temperature to grow. Therefore, if we can target and limit these requirements, food preservation can be achieved. Food preservation depends on the methods which effectively manage the microbial content of foods. They should also alter or delay the activities of enzymes in the food. The techniques to achieve these may be applied separately or in combinations. Thus, the aim of food preservation should be the first to prevent contamination, then to reduce the population of contaminants and to prevent microbial growth. The pre-processing of food preservation can be divided into three parts: proper packaging, quick and effective transportation, provide good storage facilities like silos for grains and cold storages for fruits and vegetables. Once the food ingredients or raw materials are properly handled and managed, the next step is food preservation. Food preservation methods. Methods that allow food to be kept for a specified period of time without losing its nutritional quality. The method should also prevent the growth of unwanted organisms which lead to spoilage. Three basic objectives of food preservation are: prevention of contamination of food from external damaging agents, prevention or delay of growth of spoilage organisms, delay of enzymatic spoilage by the naturally occurring enzymes within the food or self-decomposition. Food industries adopt several aseptic methods to prevent the contamination of food during processing. Industries, based on their requirement, determine the process of food preservation. For example, in the canning industry, the microbial load determines the temperature required to process. This is known as aseptic canning. In dairy industry, the quality of the milk is judged by its microbial content. Some of the methods adopted to achieve the good processed foods are: removal bar restriction of microbes. For liquid foods, filtration is a method used for the complete removal of microorganisms. This method can be successfully applied only to clear liquids, example water, fruit juice, beer, soft drinks and wine. The filters are sterilized and made bacterial proof before they are used. The liquid is filtered by passing through the filter under pressure. Inhibiting the growth and or activity of microorganisms. This may be achieved by storing at low temperature or drying, or by providing anaerobic condition or using chemicals. Holding the food material at low temperature in cold storage slows down and sometimes prevents microbial activity. All microorganisms need moisture and they cannot flourish in the absence of moisture. Hence, drying of food is a very effective method for avoiding the spoilage of food. When anaerobic, that is absence of oxygen conditions are created, most of the aerobic organisms die. The spores may survive, but will be unable to multiply in the absence of oxygen. This principle is used in canning and in packaged foods. Certain chemicals like sodium benzoate and potassium metabisulfite are used as preservatives. However, they should be used within the prescribed limit, as any excess may result in poisoning. The most common and the ancient method used is heat processing. In irradiation, gamma rays or high speed electrons are used to destroy the microorganisms. Such radiations are known as ionized radiation. This topic will be dealt in part 2 of this chapter. Prevention or delay of self-decomposition in food. Blanching is commonly carried out for destruction or inactivation of food enzymes. Blanching is a process of dipping the whole food material in boiling water or steam for a short period of time. The time duration of treatment applied varies with the kind of food. This process inactivates plant and microbial enzymes. Most of the plant and animal tissues contain enzymes which are active at room temperature. An increase of temperature by 10 degrees Celsius doubles the rate of chemical change. Example, rancidity of fats, which lead to the deterioration in flavor of food. Oxidation also leads to the loss of ascorbic acid, an important vitamin for human being. These enzymes may soften the tissue and change the color. Example, cut apples and banana. Short heat treatment can reduce the number of microorganisms on the food and enhance the color of vegetables such as peas and spinach. They also prevent secondary contamination due to damage caused by handling, insects and animals. Aseptic processing following of HACCP, GMP, ISO 9000 and Total Quality Management or TQM needs to be a part of food production. Methods to control microorganisms in food processing. Canning. Microorganisms are destroyed by heat, but the amount of heat required for the killing of different organisms. Microorganisms can exist in two forms, the vegetative and growing form, and the spore or dormant form. The spores are much harder to destroy by heat treatment than the vegetative forms. Canning is a process in which temperature of over 100 degrees Celsius and sealing in sterile airtight container is used. Such treatments kill all spoilage organisms and their spores. It also inactivates the enzymes. The packaging material for canning can be tin or glass. In this process, the food is sterilized, that is, the food is free from all microorganisms and its spores. This also prevents the decomposition of the food, making it unattractive or inedible. Sterilization also prevents pathogenic or disease producing organisms from contaminating the food. It has been found that all microorganisms, including Clostridium botulinum, are destroyed by heat. Higher temperatures kill spores more quickly. At any given temperature, the spores are killed based on the time of exposure. Some spores are more resistant to heat than other spores. If a graph is drawn, the number of surviving spores against the time of holding at any chosen temperature, it is found that the number of surviving spores falls almost to 0. Experimentally, it is found that if the logarithm of T, that is the thermal death time, is plotted against the temperature, a straight line relation is obtained. We can then write from the graph log T minus log F is equal to m into 121 minus capital T is equal to log T by F, where small t is the thermal death time at temperature capital T. F is the thermal death time at temperature 121 degrees Celsius and m is the slope of the graph. The d value of an organism is the time required in a given medium at a given temperature for a 10-fold reduction in the number of organisms. The z value is a measure of the change of d value with varying temperatures. It is possible to choose values of f and of z value to suit specific requirements based on the contaminating organism. Basically, heat treatment can be classified into 3 categories. Pasteurization. Pasteurization is a heat treatment that kills part of the microorganism present in food using a temperature under 100 degrees Celsius. The temperature used ranges from 65 to 75 degrees Celsius. There are two types of pasteurization, HTST or high temperature short time. Food product is heated at high temperature for a short time. For example, milk is heated to 72 degrees Celsius and held for 15 seconds. LTLH, low temperature long time. Food product is heated at a lower temperature for a longer period of time. Example, milk is heated to 62.8 degrees Celsius and held for 30 minutes. Boiling or heating at about 100 degrees Celsius. Most fruits and vegetables can be preserved for a longer period of time by applying heat at about 100 degrees Celsius. Inherent enzymes which initiate self-decomposition can be destroyed after boiling at 100 degrees Celsius. This process is called as blanching. Sterilization, temperatures of 100 degree or above. It is a process in which all microorganisms are killed at high temperature or radiation. The time and temperature necessary for sterilization vary with the type of food. Few examples are listed in table 1. However, the type of food determines the type of treatment and not the type of contaminating organism. For example, if the food is overcooked, major changes occur in texture, flavor and nutritional quality, making them unpalatable. Use of low temperature and cold preservation. Low temperature can lower the rate of chemical reaction and the action of enzymes. Generally, freezing can prevent the growth of most foodborne microorganisms, and the usual temperature for cold storage is 4.5 to 7 degrees Celsius. Refrigeration temperature lowers the growth rate of microorganisms, and chilling can slow down the enzymatic and microbial change in food. For frozen food, it should be stored at or below minus 18 degrees Celsius, where the enzymatic and microbial changes may be stopped or extremely slow. Dehydration. Drying or dehydration of food has a method of preservation which has a long history. In olden days, Oriental countries would dry mushrooms, dried shrimps and salted fish. Both drying and dehydration means the removal of water. Drying usually describes the process of drying under sunshine or open air. The other term, dehydration, usually describes the removal of moisture by applying artificial heat current under controlled conditions. Some of the differences of drying and dehydration are listed in table 2. Use of preservatives. Preservatives serve as antimicrobials which can prevent or slow down the growth of mold, yeast and bacteria. By preventing the growth of molds, yeast and bacteria, preservatives can improve the safety of food as well as prevent the wastage of seasonal surplus by making it last longer on the shelf or in the fridge. An ideal preservative should meet the following criteria. They should inhibit the growth of wide range of microorganisms. They should be non-toxic to humans, should not be expensive, should not affect the flavor, taste or aroma of the food products, should not be inactivated by the food, should not promote the development of resistant microorganisms, should kill rather than inhibit the microorganisms. Some of the common preservatives used in food are listed in table 3. Brining and sugar solution preservation. It means the use of salt and sugar for food preservation. Sugar binds to moisture and thus can prevent food by preventing the growth of microorganisms. However, sugar needs to be used in high concentrations, that is 65% or above. Products such as jams, jellies are preserved by using sugar. Most of the candies, both hard and soft, are preserved using sugar. Salt in high concentration, that is between 15 to 20%, it can prevent the water from being available for bacterial growth. This process is known as reducing the water activity, or AW. This can slow down the growth rate of bacteria and thus the food is preserved. Salt can be used in brine, that is salt water, or applied to food directly. Most common salt used for food preservation is sodium chloride or common salt. This technology, even though old, is slowly losing its importance due to the excess salt that is used, hence considered not healthy. Pickling is a process in which use of acids, that is vinegar or citric acid. Acids, spices and brines are in combination, that is hurdle technology, will be dealt in part 2 of the food preservation. This treatment lowers the pH and thus inhibits the growth of many microorganisms. It is more effective against yeast and bacteria than molds. About 20% of vinegar, that is acetic acid, prevents the spoilage of most products. It is used in the preservation of pickles, sauces and chutney. Citric acid is also used in the preservation of certain fruits and vegetables. Products of jams, jellies and squashes may contain citric acid. It lowers the pH of the food products and can prevent the growth of molds. Today, this technology has many ramifications as a number of foods like gherkins are exported from our country using this technology. Conclusion. In this chapter, we try to understand the commonly used process of food preservation. Many of these techniques are widely used in home or cottage industry level with minimum machineries. The main intentions are to see that uncooked food, that is raw materials, are handled carefully. Further, the basic principles of hygiene have to be practiced. Methods like cooking at high temperature and keeping them in closed container, storing cooked food at low temperatures are common practices at home levels. Understanding the D and Z values required for preventing the contamination and the temperature to which the food can be taken without losing its organoleptic character is important. Many of the foods that we use in our common day-to-day life are processed in these manners. Example, milk, papad, jams, jellies, etc. Dear viewers, the more modern technologies that the industries adopt to handle large quantity of food will be taken up in part 2 of food preservation. Thank you.